Okay, so good morning, everyone. You're welcome back once more. Now today's class will be introducing Prisma. As a recap on our previous class, we completed our Casey Notes app. We implemented authentication. We also added the Create Note controller and the Get Notes controller as well. So in today's class, we will introduce Prisma. We'll learn about we'll introduce ORMs. We learn about ORMs and then introduce Prisma ORM. Okay, so what are ORMs or ORM? We also learn about the importance of ORMs and then Prisma ORM. So ORM simply stands for Object Relational Mapper. So as I earlier told you, when we started this camp, it's a programming technique that acts as a bridge between object-oriented programming languages like JavaScript, Java, Python, and the rest, and relational databases like MySQL, PostgreSQL, and SQL Server as well, even SQLite. So how does ORM work? So the traditional approach is, in the traditional approach, you interact with the database directly using SQL queries. So you write SQL statement to perform CRUD operations, that is create, read, update, and delete your data. So this can become cumbersome. So what you want to do is you want to abstract all those things. It can become cumbersome, even error prone. It also requires knowledge of SQL syntax. I believe most of us have been interacting with databases like MongoDB, SQL Server, or MySQL without writing SQL statements, without even knowing the SQL syntax. So that is where ORM comes in. So the benefits of using an ORM is basically it simplifies data interaction. So ORMs provide a high level of abstraction for interacting with databases. So you can basically work with your data using objects and methods that map to your database tables and columns. So it also reduces boilerplate code. So ORMs handles the boilerplate code for writing SQL queries. That is saving the time and effort. So it also improves security. ORMs help prevent SQL injection attacks. Yes, prevent SQL injection attacks by automatically sanitizing user info before it's used in queries. So object relational map. The core functionality of an ORM is mapping objects in your program with tables and rows in databases. So it makes your code more readable and maintainable. So the typical ORM uses, we have you can use ORM to fetch, insert, update, and delete data from your database using our object-oriented syntax. You can define your data models using classes or interfaces in your code, which then map to the tables and columns in your database. In the relationships in ORMs, ORMs can handle relationships between tables easily, allowing you to model complex data structures efficiently. So instead of writing SQL queries that relate to each other with all those complexities, we just use ORMs to abstract all those. Then transactions. ORMs can manage database transactions, ensuring that data is consistent across multiple operations. And transaction here simply means if you want to perform an operation with data, and then you want every like one or two operations, like mapping or updating many records. So you either want all the records updates, or if one operation fails, then the whole transaction should fail. So that is where ORM comes, the transactions come in. So you call that in the transaction. If one operation fails, the whole thing fails. And we have some ORM examples, some popular ones. In JavaScript, we have SQLize, we have Prisma, and we have type ORM. We also in Python we have SQL Alchemy. In Java we have Hibernate and JPA, all of those. So ORMs are they are valuable tools for developers. So yes, and simplify their database interactions, improving code maintainability, and it also enhances security, as I earlier said. So that's basically the importance and uses of ORMs. So moving on, we have the Prisma ORM. So why did we choose a Prisma ORM, and what problem does it solve? Okay, so the reason why we chose the Prisma ORM is because it's compatible with both SQL databases and NoSQL databases. You can use Prisma with MongoDB. You can also use Prisma with MySQL, SQLite, MariaDB, PostgreSDB, and the rest of the databases. It supports a whole lot of databases. So Prisma ORM is actually an open source next generation ORM. That's what they call it. Open source next generation ORM. So it consists of the following parts. It basically consists of the Prisma client, the Prisma migrate, and then the Prisma Studio. So the Prisma client here is that is the auto-generated and type-safe query builder for NodeJs and TypeScript. So when you run Prisma generate or Prisma migrate, when you migrate your schema or you generate your schema, it's also generated with types so that you don't have to capture errors at runtime. Instead, you capture them at development time. And then the Prisma migrate here is a migration system. We introduced migrations earlier in our previous class. Prisma migrate is basically a migration system that helps you migrate up or down. So as we proceed, we learn more about migrations. So we also have Prisma Studio. So Prisma Studio is a graphical user interface to view and edit data in your database. You see how awesome Prisma is when you start using it. And everything, the Prisma client and the Prisma migrate are open source. It's only Prisma Studio that is not open source. You can only run Prisma Studio locally on your machine to view and edit data in your database. So Prisma clients can be used in any Node.js supported versions, like any Node supported version, 18, 20, anyone, or any TypeScript backend application involving serverless applications and microservices. So this can be a REST API, a GraphQL API, a gRPC API, or anything at all that needs a database that runs in Node and uses TypeScript or JavaScript. You can use Prisma. So the question now is how does Prisma ORM work? So if you want to start using the Prisma ORM, you basically have to start with the schema. So the Prisma schema allows developers to define their application models in an intuitive data modeling language. So it also contains a connection to a database and defines a generator. Okay, so I actually didn't want to set up Prisma, but I wanted us to get to a point before we set it up. But since we've mentioned the Prisma schema, I think it's a good idea to basically look at what a schema is, the Prisma folder, and then while we set it up, we will learn and then explain along. Okay, let's head over to VS Code. What's happening? So let's head over to VS Code and then what's this? Okay. Okay, so right now we create another folder here. Then we name this one 8 Prisma like this. So I guess we just navigate to this CD8 Prisma like this. Okay, let's okay, now you can see the Prisma folder. LS, and I don't have anything inside of this folder. So basically, what we will do is we first of all initialize a node project. So we create a package, so npm int/y. So now we have a package.json file in our Prisma folder. So we'll go ahead and install npm-d Prisma. Okay, so this is also known as the Prisma clip. That is the Prisma command line interface. So we install this Prisma command line interface, and then we will also use it to do some other things as well. I don't know why it's taking time. Okay. It's not supposed to take much time. I think it's a network. Okay, so let's just stop it and then run it once more. We install it as a development dependency. Okay, okay. So now we have this Prisma. We've installed Prisma in our project. So I guess we should also install the Prisma clients so that later on we don't have to npm I at Prisma as client. We install the latest version. Even if you don't specify the latest, it will still install the latest version for us. Okay, so why is this also taking time? So we come over here and then we create an index file. It's an index.ts. So inside of this index tiers, this is where, okay, so now we have Prisma client also installed. Now you can see the versions here match the Prisma version 5.16.1 matches with Prisma client 5.16.1. So we have Prisma client and the Prisma command line interface. So the Prisma command line this Prisma comes with the command line interface and the Prisma Studio. So you can run npx Prisma Studio, but we don't have any schema now, so you can't just run that. So what we have to do now is, I only wanted to show us what a schema is. So we're still talking about the Prisma schema. Let me just say npx Prisma init. Okay, now I want to initialize Prisma. Okay, so my terminal here has an autocomplete feature. It autocomplete things for me. So I want to initialize Prisma. So if you don't provide a data source provider, it will default to Postgres. Okay, so let me just leave it like this and then hit enter. npx Prisma init. So it will create a Prisma folder for us and a .env file for us. So if you open our Prisma folder, you will see that you see a schema.prisma. And inside of here, we see PostgreSQL. So and in the comments here, you can also see, okay, let me just move this aside. You can see this is your Prisma schema file. Learn more about it at Prisma. So looking for ways to speed up praise and all of that. Okay, this is not necessary. This is our Prisma schema. So we can go ahead and then do away with this one. So we now have our Prisma schema. So the client here, the provider is Prisma client JS. And then we have the data source. This is the DB. So the provider for our database is PostgreSQL, and then the URL is database URL. So we don't want to expose this. We can basically, now in this env file, we have Prisma automatically create an example URL for PostgreSQL for us. So environment, there's a comment here. Let me just zoom in a bit. Okay, there's a comment here. Environment variables declared in this file are automatically made available to Prisma. Yes, because we come here, you see it is referencing this database URL in the environmental file, in the .env file. So you can basically copy this here and then move it to our Prisma schema. Oops, here. You can move it over here and it's perfectly fine. But then you are exposing this because this database must have a username and a password. And once you leave it here like this, then you are exposing it to people that has access to your project. So this is the reason why we are referencing it from the env file. So this is basically our Prisma schema. So the Prisma schema, also known as the schema for short, is the main method of configuration for your Prisma ORM setup. So it consists of the data source and then the generators. So the generators here specify what client should be generated based on the data model, e.g. like the Prisma client, and then the data model definition. So the data source here basically, what the data source basically specify the details of the data source Prisma ORM should connect to. So the first thing here, we mention the data source. So this is the data source. This from line 5 to line 8 here is the data source. So it specifies which database the Prisma should connect to. That is provide a URL to the database this Prisma client is connecting to. So the second one is the generators. So this specifies what clients should be generated based on the data model. And the default is the Prisma client. So talking about other providers, other clients, that's an advanced stuff. Let's just stick to the default. The default can serve you in any project at all. And then the next thing is a model, data model definition. Okay, can you imagine let me just show you something a bit in our source, in our case note model. Okay, let's say database and indexed tiers. So let's assume we want to model this. So you don't even need to know everything about this thing. So let's use, for example, let's just use Prisma to model this thing here. So we can basically come over here, and then we can say model, and then we can say username, open and close curly braces, and then I will hit enter. And in here, I will say ID. ID is of type, let's say int, and it's an ID. And then I will say at default, I'll say auto increment. Okay, so it apply this, once you apply migrations on this schema, this will be automatically created for you without you having to write all of this. And then we'll get to where Prisma ORM bridges the gap between writing model you write for your application, like for your controllers, and then you write for your database. It bridges that gap. So instead of writing ID integer primary key auto increment, we just come here and then we see, okay, ID it's a primary key by saying it's ID, and then default auto increment. Okay, then the next thing in our database here is a username. Then you say username. Say username is a string, and then it's required. So by saying it's required, if you don't want it to be required, as we say not null here, this simply means it is required. If you don't want it, you can add a question mark in front, and this is now optional. It is not required. Even if you don't provide it, Prisma will not throw an error. So this now is required. So what next do we have in our database? We have password. The password is also a string. Again, we see password string like this. So what else do we have? We have created at, and this is a dead time. And then we will say at default now. So this now basically means when you look at this, you say timestamp default current timestamp. So when we create a user right now, the time will be the date will be 2nd July 1037. That is what the default should be now. But if you don't provide the default, every time you want to create a user, you have to supply this time. So now we have this. So what else do we have in this table of users? We have unique username. So if you want to make the username, you just come down here and say at unique, and then we say it is a username. Simple. And then we don't have to do any other thing. Now username is unique. As all these gibberish we wrote here, unique username, this would create table, if not exist, this and that, blah, blah, blah. Now we have it here. And then this is basically TypeScript that you can understand. This is an integer, quite all right, to auto increment. Then username string. Okay, now integer, this ID here, you can basically change this ID to a string. And then when you change this ID to a string, you get an error here. This error says error passing attribute default. The function auto increment cannot be used on fields of type string. So you have to remove this. You cannot auto increment strings. Then here you can say default. You can say CUID or the normal UUID. It is built in Prisma. The normal UUID you normally install and then you use in your applications. You can specify it here, or you can say CUID like this, since it is a string. But if it is an integer, then you will get an error here. This is saying you cannot use a string on integer type, ID type of integer. You just come over here and say, okay, auto increment like this. Auto increment like this. Okay, so now, as you can see, we have our username, model username. Okay, this is supposed to be a user and not username. Sorry about that. This is a user, the table. We are saying create this table of user with all these properties in it. So if you come over here, this basically, this is what we are doing here. So as you can see how awesome Prisma is. Okay, now that we've seen the Prisma schema in this single file schema of Prisma found in the Prisma folder. Okay, we can basically let me just copy this, and then we can basically delete this, and then come over here, clear the terminal. Okay, close this file as well. Close this folder as we've seen the example now. You can come over and say npx prisma init data source provider, and then we see it's equal to MongoDB. So now we want to connect Prisma with MongoDB. So if you hit enter, this is what Prisma will do for us. Now it has now created a Prisma folder for us with schema of Prisma. But this time around, if you open it, you see that the provider here is MongoDB. And if you open your env file, you see that, okay, we did not delete our env file. Okay, let's delete our env file, delete the Prisma folder again, and then run this command once more. Okay, so now we've seen that our env file is created. You can see this MongoDB URL here. It's created. All you need to do is just replace it with your normal Mongo, because we have root, random password, cluster. This is this is how MongoDB Atlas normally creates URLs for MongoDB databases. And if you come over here, you open this, then you see this. But then if you paste our schema, then we get an error. Okay, now we have to come over here. We see this is a string. And then you say at ID, we say at map. You know that MongoDB IDs are not just regular IDs, they have an underscore. At map ID, like this, and then the error goes, the error is no more, because we are mapping this ID to this MongoDB IDs. If you've worked with MongoDB before, you know that their IDs normally have an underscore. So we are mapping this ID to this one. So when you create a user, the user ID will have underscore. So you have to convert it to the normal ID. And then you can say at DB object ID. You know, MongoDB IDs are object IDs because it's a document database and it has to work with objects in it and in the databases. So you can basically do it like this. At ID, at map IDs, at object ID, or you can basically leave it like this, it's still fine. Okay, so this is working with MongoDB. Okay, now we can go ahead and delete this. And then delete the env file once more. We'll delete the env file, clear our terminal, come over here and say np, okay, let's go over this again. Then this time around, we say SQLite, hit enter. Always remember that SQLite is always embedded in your application. So look at what Prisma will do for us. Now look at the env file. Then we have file dev.db. Now if you open your Prisma now, you see here we have SQLite. The provider here is SQLite. Now if you try to run migrations, or you try to run, you try to evolve your schema or generate your Prisma client, if you run npx Prisma generate. Now Prisma will generate the schema for us. Okay, now don't have models defined here. Okay, so now we have a model here. Now let's save it, and then and it's even showing us an example. Error, you don't have any models defined in your schema Prisma file, so nothing will be generated. You can define a model like this. Okay, so now we can generate a Prisma client. Okay, so now we've generated a Prisma client. You can run npx Prisma db push. So we're pushing this schema to our database. Now, if you open dev.db, this is our dev.db. Now, if you delete this, come over to your env file and then change this to SQLite DB, and then run APX Prisma DB push again. That's why we're pushing our schema to our database. We're creating those tables and the columns in our database. Then we have our database SQLite DB. That's perfect. So right now, for SQLite DB, there's no external URL or whatsoever because it is embedded in our application, and then you can see it here with Prisma and Prisma clients. And you can see that the provider is SQLite, and that's perfect. So while working with SQLite, let me just state this difference sharply so we can move on. You can use enums in SQLite. You can say enums, and then you can say row. Then you say admin. Because you are getting this error because error validated. You define the enum row, but the current connector does not support enums. Okay, so now let me remove this and then delete the whole Prisma. Okay, now this time around, let's specify our provider to be MySQL. Then we hit enter. So now our provider is MySQL. Then if you open the schema Prisma, we have MySQL here. And then down here, we can basically paste this. And then everything is fine because MySQL, PostgreSQL, MongoDB, and the rest support enums, but then SQLite doesn't support enums. So then you can see user. And then you can come over here and then you can see row. And you can see row is a row of is it row is a row, is it have to be admin something? No. It's a row is a row, and then you say at default, nope, at default, and then you say it's admin like this. Okay, so now you want to create a row, you want the user to have a row, but then the default row should be, okay, let's say the default row cannot be about admin. The default row, you want the default row to be a user. And then if you create a user without supplying a row, the user will have the user row of user. But then when you specify, later you specify admin, and then the user will have the row of admin. But if you specify something else, TypeScript will throw an error that in your database, the row is only admin and user, and then you cannot supply any other row. Okay, so we've explained schema, and then we've seen how we can use schema with every other database. MongoDB, MySQL, we can generate, we can easily support different databases. So Prisma, whenever a Prisma command is invoked, the command line interface typically reads some information from the schema. So the Prisma generates, as we earlier generated the client. Okay, now you may be asking what this is all about. This Prisma, start using it. Prisma is going to new Prisma client and all of that. So when you generate the client, what it typically does is it creates functions for you. You know, in our let's reference this a bit. If you come over to our model and then auth, look at what's happening here. We have this SQL statement, and then we see how this function, we can abstract this, we can remove this and then take it somewhere else and then import it and then use it in this function. So what Prisma does for us, it creates all of this under the hood, and then it provides functions for us to basically, now we are creating this create user, and then we are calling it in our controller here to create a user. Check out, no, we have get user nodes, and then we have get user, we have create user. So the reason why I say user create user is because I know we're going to use Prisma, so I'm doing this so that when we get to Prisma and we start using it, you understand the reason why I'm doing this. So Prisma will automatically generate all these functions for you and then create the schema, the SQL schema for you, SQL syntax for you, and then create functions for you to basically call and then pass in arguments to create all of those. So you don't have to go back writing all of these all by yourself and then doing the rest of those things. Okay, so now that we can also run Prisma migrate dev. That is in. So let's migrations here. Let's assume you have your database running in production. So if you want to apply migrations in production, you simply run npx prisma migrate deploy like this. So these migrations will be applied directly in your database in production. But in this case, you don't want to, if you want to apply migrations in your development environment, let's assume this is, let's close this, come over here and close this one as well. So this is our development environment. So now we want to track the involvement of our schema. So what we want to do is we want to migrate our schema. Now we want to say npx prisma migrate, and then we say dev. So if we say dev and we don't give it a name, it will prompt us to give that that migration a name. So let's run this and see what we've got. Okay, so now we're getting an error. But the UI must start with protocol MySQL. Okay, so I say my SQL, but then in here, okay, let's not delete this. Let's just bring it here and then say my SQL like this, blah, 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 blah. So every MySQL database URL must start with MySQL colon and then some. So Prisma automatically detects that and is telling us, no, you have a provider here of MySQL, and then what you are specifying in your env file is SQLite. Okay, so now let's clear this terminal and then try it once more. npx prisma migrate dev can read database server. Okay, now we're getting this error because when we run migrations, now let's assume we already have this schema here, and then we add something to this table. We add a column to this table. So when we run migrations, that column will be added in the database. And now what Prisma is trying to do is trying to reach our database. Now let's come back here and then change this to SQLite and come to, okay, now we're getting this error because SQLite doesn't support enums, and then we'll remove it. Come over here, remove this one as well. Then come to our env file and then undo the changes. Have SQLite DB. Okay, now let's run this once more. npx prisma migrate dev. Okay, now as you can see, SQLite DB journal. Okay, so SQLite database, SQLite created at this file. So enter a name for the new migration. So we can say init, that is the initial migration. Then we hit enter. And then as you can see, it creates a migrations folder, and this migration has a date. And then the name, it's append the name of the migration to the date. Now, if you open our migrations, this is a migration log.toml. The provider is SQLite. Please do not edit this file manually. It should be added in your version control system like Git. Okay, because this is basically like Git. We are tracking the involvement of our database. Now, if you open migrations SQL, look at what we've got here. Can you see this? Create table user, integer not null, primary key auto increment, username text not null, password text not null, and then created a date time not null, default correct timestamp. Then create unique index, username key on username. Okay, so this, if you look at this and then take a look at what we wrote earlier, create unique index, username key on username. Okay, this is basically making username unique. So create a unique index on username key. That is, you grab the user and then you say user. This is another schema. It's not inside of this. And the reason why, okay, this will take a little bit of time, but then there are so many things we need to talk about here. I just don't want to jump. So I'm also keeping track of time. If we get to a point, I will stop explaining all of that. I just want you to grab the basics of what we're doing. Now, if you open the database and then go to index tiers, you will see here that we have this and then create, and then we have unique. Inside of this, we just say unique and then the username. But you can create, outside of this schema, you can create another schema and then write all of that inside. So if you open our migrations here, you can see that migrations.sql, this is where all our SQL syntax will be written and then all our functions will be generated. And if you come over here, we see user. So now let's go back to our node modules. If you go to our node modules and we open our Prisma, we will see okay, it's Prisma, and then we'll see this Prisma client. Then we'll come to default JS, not default JS, edge JS. Okay, index JS. Okay, now index JS, we're not on edge. This is Deno. Edge.js is for Deno. I don't want to go into that. Okay, now index.js. Forget about all this that you've seen here. Now our Prisma client is right here. Now you start export Prisma, export enums and all of that. So if you come over here, see that the client is version 5.16.1, and then the engine is so Prisma SQL tag and join the raw validator and all of that. We have all these things in here. So let's move over to okay, we have part go to require part, serializable and all of this. So we don't need to know all of that. So we have export prisma.user scalar field enum. We have ID, username and password created that. And then we have export Prisma sort order is ascending and then descending. Okay, all of these are things you can use to sort your records in your database. Then you come over here, have Prisma. The model name here is user. Then we have config. The Prisma config has a generator of name clients. The provider is from env var, which is null, and then the value is Prisma client JS. So the output here is this is where it will generate our Prisma clients. And look at it inside of our Prisma folder, node modules at Prisma/client. So if you open this, you see blah, 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 and all of that. So we have engine type is library, binary targets, Darwin, and you don't have to know all of this. So this is our Prisma. So the schema env part is in the env file. And then the relative part is Prisma and all of that. So I just want to show you this, but you don't need to basically know it. And then going forward, we have runtime data model is JSON pass. Okay. So as you can see, we have field name, ID, kind, scalar, is list, false, has default value, true, type, int, default. Okay. So as you can see what Prisma is doing for it, this is really, really awesome. Then you come over here. So we have our schema and everything is ready. So the reason why we only have this here, this user schema here, is because we only have a user schema in our database. So basically, if you add another model in your database, and all of them will be generated here automatically for you. But before they will be generated, you have to run npx Prisma generate to generate your schema. Every time you evolve your database, you run migrations so that those schema will be applied to your database, and then the new generated your schema will also be, your client will also be generated with all those models in your database. Okay, so that's basically it. Now we've seen how Prisma works. And the reason why I'm showing you that this is located in the node modules Prisma client is because if we have the opportunity to host our next application on fly, all of this matters, because in our next class, we'll be talking about Docker. And I don't know, some of us are complaining that some of these things are hard to grab. But I won't lie to you, I told you earlier, but what you're going to face is it's something big. Docker is another thing that comes with headache. Let me say headache, because for you to understand Docker, it's something on another level, but I believe I'll try to make us understand. Okay, but right now we're talking about Prisma, so let's not go into Docker. Okay, so now that we've explained our what's Prisma, now if you open, let me just mention this before we move on. As you can see, my schema here is highlighted. Now, if you come to my extensions and you type Prisma, I have this Prisma extension installed. You can look at it, Prisma v5.16.1, downloaded by 1,759,319 people. Syntax highlighting, formatting, auto completion, and all of that for Prisma. So you can, if you don't have this, your Prisma schema file, the schema in your Prisma schema file will not be highlighted. I have that. So that is the reason why if I type at, you can see that it will autocomplete for me at default, at ignore, at map, at relation, at unique, and all of that. Okay, so now this is our simple schema, but later on we can see here we will get to do write all of those and the relationships. Okay, so this is basically Prisma, and this is basically Prisma schema. Okay, so we can also access environmental variables in our schema as we've seen, blah, 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 all of that. So this is the Prisma schema, and that is, okay, I guess we're only supposed to talk about the overview, but we also talked about the data model. Oh, and we also talked about Prisma client setup and configuration, and then now we now know how to set up and configure our Prisma client. So basically, the next thing to do is what? Queries. I guess this is what we've all been waiting for. Prisma queries. So let's talk about the queries. Under queries, we have the CRUD, that is the create, read, update, and delete. We have select field, we have relation queries, we have filtering and sorting, we have pagination, we have aggregation, grouping, and summarizing. That is a bit of an advanced stuff. Then we have transactions and batch queries. Then we have full text search. But full text search for now, it's only supported in MySQL. And then we have custom validation, computed fields, excluding fields, custom models, case sensitivity, raw database access, query optimization. And in this query optimization, we will not touch it here. And most of these things we won't even touch them because there are things you can learn in just a day or two. Because if you learn the basics of something today and you turn to learn the advanced stuff in that specific concept or topic, that very day you won't get to understand, because you have to understand the basics first, use them, and then know how. Because if you don't use the Prisma client to like your app, you don't know where you will not know where to optimize your Prisma queries. So first of all, we start with the CRUD. This is the most basic one. Create, update, and then delete. Okay, so basically we have to first of all set up we'll come back to our index.ts file and then set up some things. So what do we need to set up in our index.ts file? We will need to set Prisma up to be able to start and stop. So what we do, if we've already installed Prisma and we've already installed Prisma client, so we'll move over to our index.ts file, and then we import Prisma. Prisma client from at Prisma/client like this. And then this time around, what do you want to do with the client? We say const Prisma is equal to new Prisma client. And then in a production grade application, you can pass in some configurations. If you hover over this, you have you have this can take some configuration. Now we've imported our Prisma client. We can use our Prisma client here. You can see we can create a user. Let's look at our schema, Prisma schema. We have the user schema. So the user schema, we're taking a username and a password. Okay, the database auto incremented. So we can say const. But before we even create a new user, we'll say async main async function. What am I doing? Async function main. Then in here we will write our schema, and then I will say main dot then we call main. This is a function main. Then async, because Prisma is, we say async function here. We say await Prisma connect. So after we are done with everything we want to do in this function, we want to disconnect Prisma. Then we can even log. After disconnecting Prisma, we can say Prisma disconnected, like this. And then if there's any error, we'll grab the error here. So .catch. So this also will take async function. We'll see if there's any error, we'll also disconnect Prisma client. So Prisma disconnect. Then we see process exit. What is this? Process exit 1. Okay, error. Cannot find him. Oh, this is TypeScript. I know I've not installed the node types. I say npm I at types / node, like this. So we don't get this error. TypeScript doesn't recognize this. This is we have to install the node types, and then I think this error should go away. Okay, cannot find it, but do you need to install types drive? Okay, the error is still here. Why is it here? Okay, let me see. Process. Okay. Since this is giving us, let's leave it like that. Okay, we can come over here and then see. Okay, we need to install npm id ts node. Let's install ts node as well, because we use, this is TypeScript, and then we need to use ts node to. I should have installed it together with a TypeScript. Say npm id TypeScript. Okay. So we've installed TypeScript. Now let's come over here and then see, try this one, some process. Okay. So npx tsc --init. Okay, so we've initialized a ts config file. Then you see process exit 1. Exit 1. Okay, so now we've completed our main function execution. So when we call this main function, everything inside of the function will be executed. So we can say const new user is equal to await Prisma user create. As you can see, we have this user is referencing the user schema in our database. This sorry, in our schema, this very user here. So we can create a user. So now a user needs data. This is the data that we take. Now we have username. Now everything is being auto-completed for us. Look at the username here. Then you can see KodeCamp. And then you can see password. Say some gibberish like this. So this is all we need. And then we say after creation, const user, blah, blah, blah. Okay, then you can see log user. user like this. Okay, so now we need to come to our package JSON here, and then we can see, is it npm? Okay. Let's say run. Then we say this is a ts node source/index ts. I hope this will work. Okay, so in our terminal, we'll clear our terminal and run npm. Okay, let's just npm run. Let's not say run. Exec. This you see npm run exec. Ts node. Okay, we're getting this error. Cannot find name index ts. Okay. It should not start, please. Type module. I don't want to default to JavaScript, and I don't want to go by setting all of those things up. Cannot find the index ts. Source. Okay, it's not in the source folder. There's no source folder yet. What am I doing? So let's learn anything wrong. ts, we type unknown file extension ts in the index ts. Okay. Let's run this once more. This should just run without errors. Okay, we're good to go now. And now we can see they created us. We have, okay, 24:07:02. And then the time here is 10 minutes after 10. It should be 11. Okay, I think my time is 1 hour ahead. Then because it was remaining 3 seconds to be 10:11 and then 11:11. Okay, so it's correct. And then we have user, the ID is 1, the KodeCamp, the username is KodeCamp, and then the password is some gibberish. So if you come over here and then change this to, let's say, code, leave this to some gibberish. So if you leave it as KodeCamp and then you try to create it, you'll get an error because you said username should be unique. So you cannot have 2 usernames in your database. Now, if you try to create it once more, you get an error. Okay. This error is silent. Create. I think create all user create all this to get errors. Okay. Let's just leave it as create for now. So we've created our user. So now, how do we know that we've created our user? So let's just comment this out. Basically, we can see user is equal to await Prisma user user find. You can use find first, and then we explain all of this later, but not now. You can use find first, and then since username is unique, I can say find unique. And inside of this unique, I can say where the ID is 1. And then you say log user. So since we don't have enough time, just pay attention, please. You need to pay maximum attention to what I'm doing. So since we don't have enough time, there's this thing I want to show you. Okay, now, first of all, we're using the find unique. So the find unique function here, let me hover over it if there's any description. Okay. Find 0 or 1 user that matches the filter. Okay, but that's not the explanation I want. So the find unique function here, it's find a unique record in your database that matches the criteria, that is the ID supplied. Now, if you supply something else, if you say password, like this, now you get an error because password is not unique. And what is the error? Say the expected types come from property where. So here type select node filter which user for each. Okay. And then it's saying type password is missing the following properties, type ID, number, or username. It should, that is, if you read this error where you discover that it's saying the unique type should be either be an ID or a username. It cannot be password. Now we made our username unique. We have this user ID1 username KodeCamp, and we can even select only the username. So this is why I love Prisma so much. So people will tell you that, oh, I don't love REST. I don't love representational state transfer. It's there's this feature I don't like, data overfishing and data underfishing. I love GraphQL. GraphQL, you just supplied it. No, Prisma solves that problem. Now, if I say select, and over here, I say username, and I say true. Now look at what will happen. Now, if you run this function once more, npm run exec. Okay, so now this time around we have username KodeCamp. Simple. We've gotten this user from the database, but it's only fetched the username. So this enhances query time. Now we will only fetch the username. We disconnected from our Prisma client. Prisma disconnected. Username KodeCamp. Simple. And then if you change this select here to ID, you say true. And you run this thing once more, npm run exec. And then here we have our ID1. Then you can say ID true and then username true. You don't need the password. Select ID true, username true. And then you run your function once more. I mean, your script, and then you have ID1 and then the username is KodeCamp. Nothing more than that. So I love Prisma. Prisma solved this problem. Then you can come over here and then you say find first. And then this find first here, you can pass in a password or a username. But what find first do is not find unique. It doesn't find a unique record in your database. It doesn't find a unique record. Rather, it finds the first record that satisfies your criteria. So our criteria here is ID of 1, and you cannot have duplicate IDs in your database. So what you are saying is find the first record in my database ID of 1. So what find unique we do is find unique, we search the whole of your database for a single ID. But find first, we not. So there are some cases where mostly you have to use find first. First, first of all, we find the first item that matches that ID. So what will happen here is we have find first with where ID is 1, and then if you run this, we still have the same result. We find this and then we return only the ID and the username. But by the time you do away with this select, you run this once more, npm run exec. Then we have ID, username, password, and created at. Okay. Okay, so now we've seen create. Take a look at the create. The create takes the data. Look at the data object. And then you can see here, even in the create, you can say select. After creating the user, you want to return the user. So you can select, then you can say ID. After creating the user, return only the ID. Then you can log the user. And then you can use select in ID and all of that. Okay, so now we have create, we have find first, and then you can even find many. And then this find many, it's fetching all of the records in the database. And then you can use find many like this, and then log your user. So let's comment out this new create. You say npm run exec. This will return an array instead of an object. So earlier, when we fetch a user, we return an object because it's a single record. But find many here has, okay, now let's create this, another user, and then let's say this is a code. And then come over here, npm run exec. Okay, so now we have 2 records in our database. We have 2 records in our database. We have the first one is ID of 1, The second one is ID of 2. So this is an array. Now we can get a user by username. So now if we comment this out, we have 2 users. Now we can say in find many, we can pass a criteria here and then say order by, and then we say username. Is it ascending or descending? You can say descending. So in alphabetical order from Z to A or A to Z. So what we do here, let's run exec once more. Okay. So what's happening here? User console of user find many order by username. Okay, I guess we should use the ID because the username is the same thing. ID descending. So descending is from 2 to 1 instead of 1 to 2. So let's run this once more. npm run exec. Okay, so what's happening? User find many order by ID descending. Let me just comment that out and then run this once more. Okay, so now we have the user with the ID of 2 first, and then the user with the ID of 1 first. But if you change this one to ascending, and then we run npm run exec. Okay, so now we have the user with the ID of 1 first, and then okay, so now let's run. This is order by. So now we are ordering the record. So we can go ahead and do other stuff with find many. So now let's say we want to, let's remove this one, comment this one out as well. Okay, so there are many things I would have loved to talk about Prisma and many interesting things, but you can see time is not on our side. So that is the reason why I'm teaching the basic. So we've learned the create. So now we learn update. So how do we update the user? Okay, so let's assume we have 2 users. We have KodeCamp and we have code. So the first user here, which is KodeCamp, we want to change the username to something else. We want to maybe, let's say we want to change the username from code to basically camp. So how do we go about that? Okay, so now we create another function. See, const updated user is equal to await Prisma user. As you can see, look at the Prisma, then the user, the schema you want to perform the operation on. So the Prisma user is the one you want to use. So now what made, if you Prisma user and then you see the dot, look at all the operations we can perform. We have the count, we have the create, we have the create many and return, we have the delete many, the fields, find first or true, find many, find unique or true. And I will show you okay, let's just comment this out. We have find first. Okay, we commented out the find first. We have find many here. Okay, so find many or find first or true. Now, this find first or true, we see where ID is of 3. Now, let's see what happens now. Let's run this npm run exec. Oops, find first or true. Okay, now grab this. I know where the problem is coming from. So try catch. Throw this in here and then see throw error. So now you run this once more, npm run exec, find first or true. Why am I still getting errors? Say return user. They are not supposed to be, I'm supposed to be getting errors. Okay, this is silently failing and I don't know why. Okay, so let's try this as well. I don't know. Let's grab this error from here, error, and then run this exec. Great. No user found. Okay, so no user found. Now let's remove this or true. Find first. Then let's run it once more. There's something I want to show you. And if you don't get an error, then I'll say what I want to say. Great. So now you know the difference between find first or true and then find first. So this normally, if there's no user found, it will return undefined. Okay, basically, we are not returning anything. Let's log user like this, and then let's run it once more. Okay, null, not undefined. So it's returning null, but then there is no error thrown. Okay, so now if you change this to find first or true, so basically you are saying if this criteria is not met, then throw an error. So if you run it once more, this time around, the error will be thrown, and then not found error, Prisma client knowledge request error, no user found, and then all these things. Okay, so now we have, basically we have other methods as well. Let's copy this and then bring it in here. Remove this, then comment this one out. Okay, now do user dot, we have create many and return, find first or true. Then we have find unique or true. The first one, that is find unique or true. Now you know the meaning of or true. That is, if you don't find the record, throw an error. But find first means if you don't find the record, return null. But find first or true simply means if you don't find the record we're looking for, throw an error. Find unique or true. If you don't find the unique record we're looking for, throw an error. Then we have update menu, we have upsert. So the upsert is a kind of confusing. Upsert here is simply using create and update. So when you want to update a record that already exists and you want to say, okay, find it first, and then if it does not exist, create it. But if it exists, update it. So upsert take care of that. Upsert simply means, upsert is a combination of update and create, but I'm not sure we touched that. So now update. Now if you say update, we have where the ID is of 1. And then we'll say the data, the create takes data, but this time around, we want to update. So we want to find a specific record to update. So we are finding this record by ID. And now this user, we'll find the user by ID of 1, and then we'll say the username should be of KodeCamp is awesome. And then we'll say update the user and return it. So we'll say log updated user like this. So we clear our terminal. Then we say npm run exec. Kaboom! Now then we have some gibberish. We created this user 10:57 seconds, and then we have down the username is KodeCamp is awesome. The password is some gibberish, but the username is now changed. Okay, so this is how to update. Now we've learned how to update. So the data you can even change. You can say the password should be normal gibberish like this. Then npm run exec. Okay, so we have KodeCamp is awesome, and the password is normal gibberish. They created that. Okay, so now let's go back to our schema and then say updated at, say date time, and then we'll say at default, we say updated at. Updated at, okay, no, not default, date time, then we say updated. What am I doing? Updated at. Is it, oh, okay, updated at. Well, I've forgotten this. default, then it's supposed to take a value, and then the value is updated that, or is it created that? Okay. So what I'm trying to do here is basically set a default value. By the time you create the record, the updated add value will be the same value with the created add value. But when next you update, the updated add value will change. It will change to the time you basically updated the record. Why the created add will remain the same time you created the record. Okay, I think this is not oh, okay. Maybe I will remember it and then get back to it shortly. Okay, so now that we've updated the user and so we have delete. Okay, so now let's delete the user. We'll delete the user and return them. Then we'll say const deleted user is equal to await Prisma user. And we have delete. Then we say where ID is of 2. We want to delete the user ID of 2. Then we say after deleting the user, return log the user. Let's see the person you deleted user. Then we run our function once more, npm run exec. Okay, so now we've deleted this user. So this user is no longer in our database. So if we comment this out, we have find menu function here. Okay, we change it to find true. Okay, let's say const users is equal to await Prisma find my user find oops, what am I doing? Find many like this, and then we say log users. Then we'll come over here and delete it because we've deleted the user. Users, not users like this. Then we'll say npm run exec. Okay. Okay, so got it. It's updated. Okay, Toby, thanks. I didn't see your this thing on time. It's updated as we have updated at. Is it at? Is it update time at updated at like this? Great. Thank you, Toby, for reminding me. So this is it. Okay, so now let's go back and update. Let's go back and update the record first. So now we have, where is the update? We have this update. And then we'll change this to back to KodeCamp. And then let's run npm run exec. We'll update it and then we'll find many. Okay. Okay, so in our Prisma, we did not evolve our schema. So we say npx Prisma migrate dev -- name. Then you say add updated column or anything that you will. So if you run this now, we have some changes. So we have to have migrate dev create only. Then we have this migrate dev -- create only. So user table with that default value, there are 1 row. Okay. Now this will not be applied because we have a user that is created, and then if we add an updated add, it will not be reflected in the default user. So what we do is npx Prisma Now it's asking us if it should delete the existing. Yeah, we'll say yes. Okay, so now we can add our migrations. Create only simply means say yes, and then now that we've applied our migrations, it has created these migrations here. Nothing is in there here. Okay, so it has created it but not applied. That is the reason of create only. It has created these migrations, but it has not applied it in our database. And then we have pragma. There's the reason why we're having this pragma here. Defer foreign keys off, Prisma foreign keys on, and all of this. We've alter table, new user renamed to user, drop table, username, okay, we have new user, created that ID password username, select created that ID. Okay, so it has renamed the user to new user in order to apply this updated add column that we basically create here. Now, if you run npx prisma migrate, hit enter. Okay. Okay, npx prisma migrate dev, we have dev here, and we hit enter. Okay, so now it has migrated. Now, if you open here, nothing is here. Let's delete this basically. That was the first one, maybe. Okay, so now if you open this, please. If you open this, please, what am I seeing? Put my foreign keys off, default foreign keys on. Okay, so we've gotten a warning. So pragma foreign keys earlier was off, and then the default foreign keys was on, if I'm not mistaken. Yes, the pragma foreign keys earlier was off, and then the default foreign keys was on. So now what the first thing, what it does is rename our user table to new user, and then apply this updated at default time, not now. Now we have, okay, let's delete this. And then let's go over this process again, but this time around, let's pay attention. So we have create only, add name, update, add column. So we say yes. Okay, so now let's open this. And then we have, so the default foreign keys is on, then the foreign keys here is off. Okay, we don't have any data. We have to create only. You know, let's see. We want to, let's apply these migrations. Okay, no changes. This is SQLite and this is not production. Okay, I'm seeing no changes, but our migrations have applied. And if you come over here, this is our first migration. There was no updated add, and this is our second migration. Okay, so now let's delete this once more. And then come over here, run this without create only. I will say dash name, and then add updated as column. Okay, then we say yes. Okay, now let's open this. It has directly created this updated that it has renamed our user to new user and then created this. So what it's doing is, if you check Git, whenever you commit code, so the code you have a new version of your code. So you have the old one, then you can roll back to your old code, and then you have the new version. So this is what this is trying to let us understand. So we have a new version, though we have our user, we still have our user. So alter table. So we have data definition language in SQL and data manipulation and language. So we have drop table. Drop table here, it has deleted this table, and then it has altered the new. First of all, it creates a new table of new user, applied our changes to it, and then it insert this updated add. It insert all of this value to the user. this created an ID password to the user, and then it drops the table of user. It alters the table of this new user, and then rename it to user. After creating the new user, applying this updated add, it then drops the table of this user, the initial one we had, and then it alters this new table, and then changes the name to user, and then this create unique key of username that we already wrote. Then it does. So all these things are handled under the hood for us. Prisma handles this for us instead of doing it by ourselves. So it makes sure there are no errors, so that if you want to roll back, it will roll back to this user with these changes, and the updated add column will not be there. So we've applied these migrations. So let's go over and then create a user. Where is this create user? User Prisma create KodeCamp. Okay, and then we have some gibberish. We have what's npm run exec. Great. And now we have created that the same time with updated add, but slightly different. We have the seconds of 1, and then the updated is 2120, is it millisecond or whatsoever. Okay, now if you go ahead and then update this user, let's comment this one out, and then update this user, KodeCamp, this normal gibberish, and then we'll go over here and then see npm run exec. Okay, so this time around we have our user. Our user was created 10:40:01, but then we updated it 10:40:37. So now you can see the time we updated that. Now you can see what this updated at simply means. The time we created, the time we update. Now, if you update this user again, the time will change. Anytime we update the user, the updated at column. Okay, now it's 10:40:57. Great. So what else have we not done? We've updated the user, created the user, and we also deleted the user. Okay, so now let's do some surprising stuff. Let's say play our terminal npx Prisma Studio. Oh, hit enter. Wow. And now, kaboom, we have our studio. So the only schema we have now is the user. And then if you click on the user, you see you have the ID of one. We have only one record in our database. Username here is a string, password is a string, created that and updated that. Then you can come over here, click on this, and they say KodeCamp is fire on the username. Then save your change. Then if you come over here and then do something like, let's open another terminal down here. Then let's cd to it. Okay, npm run exec. Kaboom, this time, okay. Oh, this change is not synced. Okay, we've saved it. But why is it not synced? We have KodeCamp. Okay, our app is not running. We have save, refresh. Okay, now let's see. We can run exec. Okay. What is happening? Find many. Okay. Okay, I don't know what these changes are discarding, but okay, that's just it. And we have our record. Okay, but this is our Prisma Studio. Now, if you create another record, we have create. Let's open this and then see KodeCamp like this with the username of KodeCamp, and then create npm run exec. Okay, so now we have two users, KodeCamp and KodeCamp. If you come over here and then refresh, we have two users, user with ID of 1, ID of 2, and then they have it. So if you come over here, close this. So this is Prisma. So let's see, close. We have only all models. We have recently opened user, and then we have all models. We only have the user, and we have 2 records in our user model. So let's go ahead and then create in our schema. We see the user. So let's emulate notes. Let's say model notes. and then we say ID. Let's just copy this, bring it here. Every table must have a primary key, and the ID serves as the primary key. Now we come over here, and then we see ID, and then the node must have a title of what's this? No, what am I doing? Okay, title of a string. And what else? Must have a title of a string. Nothing else. I think the title is, I think we have created as, let's say created at. And this should be all. Title of a string created at, I think just for testing purpose, this is all. Okay, so now we have a user. We have user ID of string. And then we have user, and then we reference the user here. And then we say at relation, we say at relation, we have references first, reference ID. Then we have the field of user ID. Okay, so what else? Okay, so this is saying error passing attribute relation. This the type of field user ID in the model is not matching the type of reference field ID in model. User ID. Okay, user ID must be an integer because the user ID here is an integer, and here also must be an integer. There's the reason why we're getting an error here. Okay, so once we save it, look at the notes here. Let me remove the notes. Poof, and then okay, let me remove the note, and then we get this error because we're not referencing notes here. So we save it once more, and then we have notes, and we can change this n to small letter n. We have notes. We can say notes like this, notes. Okay, now this is a many-to-one mapping. Okay, let me explain this. Oh, it's really sad we don't have enough time to explain all of this. The little we have, let's just manage it and then do something meaningful. Okay, so now we have a user. A user can have many nodes, but nodes can only have a single user. Okay, now that we have this, let's see, npx Prisma migrate. Let's say add nodes like this. Then we have another migration here. We open this, the latest one here is add node. Then we open here. Then we have create table node. Then you have user ID integer node now, and then constraint node user ID foreign key. Foreign key is user ID. It references the user. Then ID on delete, restrict, and on update cascade. Okay, now let's go back. On delete should not be restrict. On delete, it should be cascade, and on update is already cascade, but we can say on update cascade like this. Okay, you may be wondering what is all this. So what we are trying to say is, anytime you delete a user in your database, the note associated with that user should also be deleted, because you cannot delete a user and then leave note. Okay, let's go back to our casing notes. I guess we did something like that. Let's open up our database index. Have foreign key on delete cascade. Great. So foreign key user ID references user's ID. So when you look at this and then you look at what Prisma is doing, Prisma is just simplifying things for you, but then we have on delete cascade. That's anytime you delete a user, delete the user's note. Then look at this is how we do it in Prisma. So how we do it in the data in using SQL here is, this is the user ID and it is not now. Then the foreign key here is the user ID. Then it references the users and then the ID of the user here. Okay, so if you come to Prisma, user here is relation, references ID in the user here, and then the field is user ID. We're looking for the field because we're explicitly specifying the user ID. So we're using the field. Then we're saying anytime you delete the user, delete this record. Anytime you update the user, also update the record. Okay. So now if you come to your migrations here, you can see that what is here, where is it? Oops, I've closed the file. Okay, Okay, this what is there is something as if delete restrict. And then if you come over here and then say npm add node 2, if you run these migrations again, another one will be created. This is another migration, but this time around, if you open this migration and then you see that our former migration then down on delete is cascade and on update is also cascade, not restrict. But this former migrations, it was restrict, and then we've applied another migration. Now you can see how your database is evolving. You started out with this, and then followed by this, and then followed by this one. So your database is basically evolving. Then you can come over here and then see, okay, migrations. Okay, now I have all of these in my database. Now you can check the dates of the migrations, 2024, July 2nd, 10, 37, 40 seconds. And the name of the migration is like this. Let's expand this. This is the name of the migration. Okay, so now if you want to create a user, it's up to you. Now, if you want to create a user, you can say data, and then you can say notes. Notes. Note is an array. You open it, and then you say a single note can have an ID, title. What's the note saying? So as an able to parameter, okay. Nope. Note, and then we have title of note. Note array. What's this? Okay, in creating notes, I think, is it an object or another object? Okay, let's say title of notes. Some notes. Then let's see the error. It's saying object literal may only specify name proper and title doesn't exist on type no object. Okay. We have a title of string. Okay, I don't know the reason why here, but then I don't know if it's an array or. Okay, you can basically create a note together with the user here, but basically I've forgotten the syntax. So now that we have a user, we can create a note. Let's basically say we want to create a note, and then we can come over here and say node is equal to await Prisma node, and then we say create. And in here we say data. The only property we supply is the title. Let's see, some KodeCamp notes. Okay, and there's something else. It's referencing okay. And so now that we want to, a user is created. We already have this user that we want to associate this note with. So there are two things we can do. We can say user ID. Then we can say user. Okay, we can say one. We want to associate the user of the ID one with this. But if we don't want to explicitly do something like this, let's say a user is already signed in, you can say user. Then you can say create or connect. So if there is no user, okay, in saying connect here, you're saying ID of one. What you are connecting this user with the user ID. So this is the user ID. Okay, but what if, okay, I'm getting an error here. I think it should be removed. Let me see. Unterminated. Okay. This is should be okay like this. Okay, so now the error is gone. So now we are sure that we already have a user. I want to connect the user with this user ID. Okay, let's assume we have a function. Most of you are confused about what I'm doing here. Let's say we have a function. Function create note. And then we have this is an async function. Now we can even move this outside of this function, then drop it over here. And then in here, we can have the title, user ID of string. They are both strings. This also here will be of a string. So in here, you can see return. Okay, you can see await or say Prisma node create. And inside of this create, we see the title, enter, then we see title is this title. So since in year 6, you can see instead of saying title like this, we can simply leave it as title is the key and the value. And then we can say user ID, and then you say it is a user ID like this. Okay, user ID is not a string, but a number. Then if you specify it, that's why I love Prisma. Prisma is typed and it's signifying that, oh, this what you're doing is wrong. Okay, user ID is a number and not a string. So now we can create this. But if you don't want to explicitly pass in a user ID, you can say create, you can say user, here is create or connect. You can see okay, what is it saying? Where ID, okay, let's say user ID, and then the data, there or where ID number but required, okay. ID number but required, create is declared here, connect or create. Okay, so this one also want to give me some issues. We have where they should be use, what is this? ID, yeah, ID, and then we're getting an error, and the error is saying create is missing in type where ID number or required in type user create. Okay, create let's say I say user. Okay, this time around you say okay, username of user, password of something like this. We create. What is this saying? Okay, this is a colon and not a semicolon, like this. Okay, so now what you are trying to say here is create or connect is simply a function that, okay, you want to create this node, and then you are not sure if this user is created. So connect this user with the given ID, and if the user does not exist in the database, then create the user with that ID. So in this case, let's say ID is equal to 3. And then let's say, come over here and then let's comment this out. You see user is equal to await create node. Okay, node is equal to create node. And then we say, let's say some node of ID 3. This is the title of the node. So let's run npm run exec. Okay, so now let's take a look at this. So what we are getting is the user, but not the node. So if you want to get, Prisma automatically enables a minimal fetching. Now we have this user with ID of 3 and so on, but you don't see any nodes. So we're saying, okay, now we pass the ID, but the user is not created. So we create the user and then associate them with this node. And then in here, you say find many. You say include. This time around, it's not select. You can say select. You can say note, and then say true. Like this. You are finding user and then selecting notes. And then let's see what we've got. Okay, so now we have the first user has no notes. The second one has some notes, and the third one has some notes. Okay, but now we are saying select. We're only selecting the notes, but we don't want to select notes. We want to bring back the user and then include the notes with the user. You say include. Now you've seen the include function, and then we say notes true. You've seen what select does. Select will only select the data you've specified. Now we say note, but this time around, we want to bring back the users with their notes included. So let's run this once more, npm run exec. Okay, so this time around, we have these users with their notes, and then we have this KodeCamp. Okay, so the reason why we're getting all of this is KodeCamp, create notes, user connect, okay. So this time around, we are creating the notes, and then we are connecting the user over. So that is the reason why the first users with ID of 1 is this notes are also be created. Some KodeCamp notes, some KodeCamp notes. And so create is not idempotent. And idempotent means it will occur anytime you call. It's not like delete, but delete, once you delete an item, you cannot delete it again. So it's idempotent. Once you call it once, the subsequent request will not take any effect. So now we say include. But if you don't include, Prisma will only return the user and will not stress itself getting the related records. So this time around, if you run this one again, this time around, say include notes. You are not saying you should include the user notes, so it will return only the user. So let's check let's come over here. Okay, so this time around, okay, refresh. Yes, what's happening? Please stop it. npx Prisma Studio. Okay. Okay, so we have notes. We have 8 notes, and then we have 3 users. So if you open this time around, now you have notes. We have notes. So this user has 0 notes. This one has 4 notes, and this one has 4 notes. So if you open notes, okay, if you open the notes, you can open the notes tree here. And then if you come over here, you can see that the user 1 has 4 notes. So this note has a user ID of 1, 1, 1, 1, and 1. And then this is the ID of the note 2, 4, 6, 8. So this user here, this note here has a user ID of 3, 3, 3, 3. And the ID of the note is 1, 3, 5, 7. Okay, so let's not worry about explaining what these IDs are all about. So this is how we can connect records. Okay, so now let's come over here, comment this out, comment this one out as well, and then try to, let's comment this one out. And then let's do something like, we have a delete, okay. Let's delete the user with the three. More npm exec. Okay, so now let's come over here and then refresh. Okay, so now the reason why I say it's idempotent is because if you run this, it will run again, but the record to delete does not exist. Okay, I will promote. Okay, if it depends on how you are. Okay, now because we already deleted the record, so it cannot be deleted again. It does not exist. So let's refresh. Okay, so this is sweet, and now we have the user of user sum, the user notes. So the user with ID of 1 has 4 notes, but then the user, there are no other, those are other notes associated with the user of ID 3 are no longer there. The reason why is because when we deleted the user, we already specified here that if we delete this user, all his associated notes should be deleted. So his notes were all deleted. Great. So this is Prisma. We're out of time, and I hope we enjoyed our class. What did we not touch? We touched almost everything in here. We have the Prisma migrate. the getting started, the workflow, even though we didn't follow our slide, but then we followed it actually because we migrated our schema. We get started, we explain what migrations are, the workflow, how if you want to create in development, this NPX Prisma migrate dev, but in production, you see NPM Prisma migrate deploy. Then we have the tools, we have the Prisma CLI, which we have been using to manipulate our Prisma and then use it also to make our client also work. I will have our Prisma Studio, basically. So this is our Prisma CLI running NPX Prisma do that, NPX Prisma do this. That is basically our Prisma. And then if you revisit our node modules, and then we'll go to Prisma, and then we'll go to index.js. And then this time around, we see that we have the nodes here, nodes, node scalar field enum, we have ID title created, and then the user ID, which is referenced. This user ID here is the one here, actually. So a user can have, I wish we can also explain relationships. A user can have a lot of nodes, but then a node can have only one user, because how can a node have enough users? No, a node should have only one user. So you can basically come here and say users, and then you say user like this. So now we've changed our schema. This is a many-to-many mapping. Now a node can have plenty users, and then a user can have plenty nodes. So we can do this, and then we can come over here and then say nodes. We can say add relation. Node here is of type node. We can see add relation, and then we have references of ID. Then we have field. Okay, let's say field is node ID of int. Then we have field. Then we can see the field we are referencing where is the node ID. And then if we save this, let's do away with this. Okay, this one is saying the line is not valid field attribute definition. Node at relation. Okay, there should be a comma here like this. Okay, so now we've changed this. So a user can have, sorry, a node can have only one user, but so node can have plenty users, but a user can have only one node. So we've changed the schema. Please take note of all these things. We'll still talk about all these things though. Nodes can have plenty users, but a user can have only one node. So if you come over here and then say user, and then grab this one. This is still a one-to-many mapping, but in reverse order. If we say user like this, and then we'll come over here and say user ID of int, and then we'll come over here and then say user ID. Okay, so now we're getting an error here. How to fix it? We'll make it at unique, and then we're still getting this error here. You have to provide it only. Okay. Okay, the solution to this is to the field argument. You have to provide only one of the two fields. Okay, you can see node ID option. Okay, here it is unique, and then I say at unique. Okay, so a one-to-one relation, a user can have one node and a node can have only one user. Okay, you can, it's a way to go about this. Okay. Let's say I've forgotten. You can go ahead and figure that out, but this is basically Prisma. And then we can also head over to this place and then say Prisma like this. Okay, so now that we've headed over to Prisma, you can say get started, or you have product, ORM, we have resources. If you head over to docs, resources, we have the tutorial, we have the playground. Okay, I wanted to talk about the playground. So the playground is, we have the Prisma client. Now, if you come over to the Prisma client, we have the find first or throw, find unique, and all of those. You can come around here and come over here and play around with this one. Okay, if you can come over here you can run the schema, the index.js, then you can view the Prisma schema. Look at the Prisma schema. Oh, and this is wonderful. Okay, then this is the index.js, then you can run the schema. We have the and, we have contains, we have equality greater than every other thing, pagination and sorting. It's unfortunate we don't have time to go over this. We have the create many. We can create many records at once, update record, delete record, obsert many, obsert record, nested right, advanced pattern, we have batch, interactive, and all of those things. Okay, so let's go back um, in the playground, and then we have Prisma migrate. Learn how to evolve your database schema with interactive guides. Now create a column in a table, delete a column in a table, rename an enum, delete an enum, create an enum. Then also here we have define an explicit many-to-many relation, define an implicit many-to-many relation, and then define a one-to-many relation. We have also defined a one-to-one relation. Okay, great. So let's see it here. Great. So this is what I mistook here. So instead of this, we should have said, okay, remove this one, and then give it something like this. And then the error is gone. So we have a one-to-one relation here. So this is sweet. Now we have a one-to-one relation. So there was a mistake I was making, and I totally forgot. So when you come over here, you read this, and then you say done, and then you see, you go over here and you click next. So when you click next, the command line will be open to you, and then you follow these instructions. That is dev user profile deletion, and then you go over, and then your migrations will be created. Now, when you come over here and then you run this nps Prisma migrate dev -- user profile deletion, your migrations will be created, and then later you come over here to next, and then you have your schema, the main include profile true, this in-depth, and then you say great, your feedback, or you go back. Okay, this is basically your migrations, how to create a one-to-one and then evolve your database. You can come over here, play with things, make sure you understand everything, and the Discord channel is there for us. Delete and you create a column in table, delete and everything. Okay, so if you want to read the docs, you can come over here. And in the product, we have the resources, we have the documentation. Under the documentation, we have the ORM. If you click on the ORM here, you have the overview, the Prisma schema, Prisma migrate, the reference, the tools, and then the field types, extension, everything. You have testing. If you click unit, if you have unit testing, and then everything, and everything here, you can set up ES module, jog, mock. You are using Jest, context, Prisma clients, deep mock proxy, and then we'll talk about that in our next Okay, so let's not talk too much. There's a lot of things here to cover, but then I'm happy to introduce it to you and then make you understand the basics, and then you can carry on from there. And then in our next app, we'll also talk more about Prisma, and then we can use it to rebuild our nodes with Nest.js and Prisma, then we test using unit testing. And then we rush it so that we have time to deploy, so that you understand everything in depth. Okay, so we've come to the end of today's class, and if you have any questions, please, you can go ahead and ask. Okay. Any questions?